For this next example, we have a pretty simple description of the scenario. We know a runner can sprint at a constant speed of 8 meters per second. I know it's not realistic to assume someone can run at a constant speed forever, but just for simplicity's sake, we're going to assume this runner can keep their speed at this constant rate for however long we want this runner to sprint. So first scenario, or first question, we're asking how far have they sprinted after 3 seconds if they were just going for a while. And for 3 seconds, if we know that they're sprinting at 8 meters per second, for each second, essentially they're sprinting 8 meters over here. And to calculate the end result, we can multiply by 3 seconds over here. To do this, we'll get 24 meters as a result. And if you check the calculation, it should make sense because it would just be 8 plus 8 plus 8. And now for part B, if we want to find how far have they sprinted after 5.5 seconds, because time can be any length over here. If they have done 5.5 seconds over here, then we would do the same process and multiply the 8 meter per second speed by 5.5 seconds over here. And as a result, we would actually get 44 meters over here. And if you look at what we did with a different time amount, we can see that in parts A and B, we just use the 8, which is how fast the runner is going, multiplied by the time. And this is a very common formula, not only in math, but also in physics. When you go through the calculation, we can say that we get to the formula distance is equal to rate multiplied by time over here. Rate being 8 meters per second, time is given in different scenarios. So in order to find the total distance, we just multiply them together in order to get the final result. Now in part C, if we want to find how many seconds will it take for them to complete a 100-meter race. Now in this situation, we already know the distance is 100 meters, and we already know the rate. That means we're looking for the time over here. So if we let the time be t over here, we would really have the formula with information as distance being 100, rate being 8, and we can multiply 8 by time over here, which is t. And to get t, we are just dividing 8 on both sides, and therefore we will get 12.5 is equal to t, which is time. And because it has a real life meaning, we want to make sure we carry the units over here. So we would say that it takes the runner 12.5 seconds to complete the race. Now similarly, if we want to find how many seconds will it take the runner to finish 45 meters, we'd do the same thing. We would get 45 is equal to 8 times t over here. And now we're again solving the equation, so we're really looking for what's the input of time for this scenario. So over here, if we go ahead and find t, we'll get 45 divided by 8. So t here equals 5.625 over here. And we would say it takes 5.625 seconds to complete the 45 meters of a distance. And now if we look at what we did in these 4 parts over here, in parts A and B, we're just evaluating expressions over here to find a final result, and that's how we can get the conclusion in parts A and B, versus in parts C and D, just like before, we had to set up an equation and solve the equation in order to get to the answers for these questions. So similar to what we did before, in parts in A and B, when we only had to calculate things, we don't have to solve anything, that means we already have the input and we're just looking for the output. In parts C and D, we had to solve an equation because all we were given is the output, and we're trying to go through the process kind of reverse the whole process of how the function is defined and find the input. So in parts in C and D, we say we already know the output and trying to find the input. And with that information, we can say that for the input, this is going to be the time that we have. And just like in parts in B, if we're given the time, we just need to evaluate the expression over here, which was measured in seconds. And with this, we can say time can be taking any value that's positive over here, because it doesn't make sense to have a negative time in our scenario. It's a little meaningless to have 0 being the time in our scenario as well. So we could say it's all positive real numbers. You can also use the interval notation that we have done a bunch of times, calling it 0 to infinity as well. Similarly, for the output, we can see the distance is going to be the output, because in parts C and D, we're given the distance, which was measured in meters. And for the same reason, we can't have negative distance really, so we're going to have all positive real numbers again. Again, you can use the interval notation if you want in this scenario.